Okay, so I think we'll get started. So welcome everyone. I'm Praveen Salitra, Director of Technology here at eGen. And after a year of a break, we are back. Although online at this point, and hopefully lives are back to normal by the end of this year, or at least mid of this year, and we are back to office or in person doing this kind of meetups. That's the whole idea. But until then, or maybe even after that, we'll try to also keep up with online version. There is definitely benefit of an online version as well with respect to the outreach that we can do. And then, of course, an excuse to do a recorded version as well. So let's get started and spend maybe the first few minutes talking about eGen. Not many of you may be aware of what eGen does. So eGen is a modern data engineering and cloud modernization firm. We are here on the southwest side of Chicago suburbs. So to be specific, in Naperville. And we have been building solutions using cloud native architectures for startups and ecosystems. I would say mostly about 6 years now. Our solution arm was created around that time in 2015, working with some of the top valued unicorns out of Chicago. So definitely we have understood the importance of cloud native technologies, real-time data streaming, and microservices and all that kind of modern architectures that we talk about. So, and that's where some of the solutions, some of the ideas that we have, our teams have been building here, they are in the world of industrial IoT, anything. And again, this is the start of Industry 4.0, right? In 2014 and also. So we have been working with a couple of largest OEMs in the world, and we have been working since almost 4 or 5 years ago since then. So we have understood the importance of real-time sensor or machine data, played with a lot of contextual data as well in terms of weather, geography, and then dealing with a lot of old school legacy enterprise systems as well. We have few of the customers in the healthcare domain as well, where we are dealing either with EHR or EMR integrations, pop health analytics, and then bioinformatics analytics as well. Different kind of environment. You have more unstructured data as well compared to the industrial IoT. But then you are dealing there with some legacy data interchange and very legacy code formats as well. So if you can find RESTful there, you will be probably happy. It's not there. So we are dealing with mostly file-based and some of the old school data formats. I think in the last couple of years or so, we started working with some of the retail customers and enterprises as well. And that's typically in the delivery world or delivery economy, but then also some traditional enterprise grocery retailers as well. So the whole idea here in this particular meetup is actually to talk about all our experiences, especially the learnings from these bleeding edge solutions, platforms, technologies that our product and engineering teams are working on or developing it. So whatever we experiment on the ground with our projects and coming up whether with the practical and modern ideas, the whole idea is to share all that in this particular meetup. And that's what actually that variety that you have shows up in our technical stack as well. Whether using JavaScript ecosystem end to end in some of our solutions, some of our works, whether backend, front end, mobile apps, or even cloud infrastructure provisioning using JavaScript stack, we have been doing it very well. Or dealing with enterprise friendly backend stack, right? Whether you're talking about JVM world, we started exploring Kotlin as well, or .NET, and then of course Python, Ruby on Rails in some projects and things like that. Most of our secret sauce and a lot of our experience actually in data engineering comes from our handling of streaming data, starting with industrial IoT, but then using those concepts now to work in the world of fintech, retail, and then also some business processing applications as well. So over the last 3 years, we have also grown on last two of those stacks there, specifically with cloud infrastructure provisioning, whether it's all about infrastructure as code or immutable infrastructure. And we have now partnership going on with AWS, Azure, and Google Cloud. We love, our teams actually love automation, whether those are for deployments, infrastructure provisioning, or data pipelines, and also operations, day-to-day data operations cases as well. So if you are interested and if you want to work with us, head over to egen.solutions/careers, and many openings in engineering as well as product and some other functions as well are available right now, and they are always available. So you can head over to that particular link and apply for a job. So that brings us to today's meetup. And today, the idea that we have here is to talk about how you can integrate with other legacy systems, in a real-time fashion. And that's what we're going to be talking about. So we have Arif Lakhani, who is a software engineer at Egen. He is one of our engineer working on a retail customer. And then he has been working through some of the real-time integrations with third party. So he is bringing a lot of experience with that domain. So take it over, Arif.
All right, thank you, Praveen. Let me quickly start sharing my screen on the presentation. All right, yeah. So here's where Praveen left. So I'm going to start here. And as he mentioned, the topic for today's discussion is real-time data integration with webhooks. Now, before I go into the topic and talk about it, I want us to realize and answer this very important question. Uh, what is the big picture here? What is the business problem that we're trying to solve here, right? Because if it is not making our lives easier, right, is it even worth solving this problem, right? So the big picture here is that it's 2021. You want to get rid of cron and batch processing, right? Nobody likes batch processing or cron jobs in general. We all love the idea of event-driven architecture, and we all want something that is real-time. Data comes in, you want to process that data as soon as it comes in. We want to get that real-time speed, right? And whether or not your organization is a small one or a big one, there's always some services that are legacy, right? And if you have legacy services, you've also probably faced this situation where you had to make a decision on whether or not you'll upgrade that service, whether that is a priority or adding new features is a priority. And then most of the times, you don't want to spend a lot of time in upgrading those services. Rather, what you do is add features onto your platform, right? So when you start working on advanced stuff like streaming services, you have part of your architecture that is modern and has all the advantages of the streaming service. But then you also have a part of your architecture that is still legacy. And that is where the problem arises, right? Not just your internal systems, but if you have, say, something like a third party collaboration and their systems are not up to date and cannot handle the tech stack that you have, then you have a problem. And this is a big problem. The problem is basically integration. Integration is the key word here. You want to integrate with legacy systems, third-party systems, but it is in some cases just not possible to upgrade them to a tech standard that you already are trying to use. So what do you do in that situation? That is the problem that we're trying to address. That is the big picture of this conversation in general. So just taking an example here, if you talk about deliveries, Uber Eats, right? As a consumer, if I want to order something from, say, McDonald's, I'd place an order on Uber Eats. Now, we all know Uber as this shiny event-driven distributed platform where each order is considered as an event of its own, right? And they process it event by event. But McDonald's, on the other hand, it might have an older legacy system that might not be able to pick that streaming service right from Uber, right? They might not have the architecture that could take in orders that come in as they come in, right? But the challenge here is for Uber to deliver these orders onto the POS systems of McDonald's directly, so that integration, that communication is seamless and real time, right? So let's based on this example, let's try and look at different scenarios and different challenges that might come up, right? So we've listed down a couple of scenarios for you guys to better understand this problem, right? Starting off with the thing we just talked about. Let's say you have implemented an event-driven architecture internally, but your external partners, third party services that you want to collaborate with, they're just not ready for it yet, right? And that is one scenario. The other scenario might be you have a legacy system internally, right? And part of your architecture is brilliant, is all stream based, event based architecture, but another part of it is a legacy system that wouldn't just work with your streaming service. So the obvious choice in that case would be to upgrade the legacy system, but again, as I mentioned, sometimes it's just not a priority. It's the other things take priority over upgrading stuff, and we got to look out for different options to solve this particular problem, right? The other scenario is that your platform has many ways to ingest this data, and you want to send this data out in real time, right? We all, again, love real time data. We want to put the data out as soon as we get it. So these are the three different scenarios, and this is just a different aspect of looking at the same problem. So three different aspects. Again, the problem still remains the same at its essence. Is that we've got this uh, great architecture internally, but there's some legacy systems and some third-party vendors that are causing the bottleneck. So the problem again is the same, just different ways of looking at it. Let's see what challenges we have because of this problem, right? Now that you're trying to implement this streaming-based platform, right? But you're not totally, or you cannot take the 100% advantage of the streaming platform because of the bottleneck, and that's the natural definition of a bottleneck. It just makes harder for you to basically utilize the 100% capacity of this beautiful platform that you're trying to build, right? So that's one. And again, you want to push out data to all the other services in real time, and then you don't want to spend time upgrading these services, as I mentioned before. It's just not sometimes a priority that you would go and upgrade these services, and sometimes it's just not even possible because in some cases your services might be really old, right? And it might be worthwhile just to keep them up until a certain point and work with them as they go along, rather than upgrading and fixing them. So that is a few challenges that come along with architecture like this. All right, so let's talk about options. So what are our options in this situation? What do you do when you face a situation like this, right? Let's go a little simplistic way. Left side consumers, right side producers, right? We're basically breaking our problem down into consumers and producers. Starting off with polling. So this is the most basic way of solving the integration problem. And to simply put, polling is when a client requests the information from server every set interval of time, right? So if I'm the client, I'm just requesting for new data every 500 milliseconds, say, right? And if there's new data available in the at the server is going to pass that new data back to me. If it is not, I'm getting the same old data back. Maybe I'm getting a null response. So that is the simplistic way of solving this problem, polling. And then there is streaming. Streaming again is one of the best ways of solving this problem. It takes the whole producer consumer problem and solves it out. Producers can produce onto this streaming platform, and consumers can consume at their own rate. And then finally, we have webhooks or rest hooks, which is the topic for the hour, and we'll look at it in more detail. But the basic idea is, rather than consumers polling the producers at every interval, what we do is we register consumers as a subscriber with the producer, and then the producer basically maintains this contract that whenever I get something new, whenever I have updates for you, I'm going to push that data to you rather than you polling it repeatedly with me, right? So that is the basic idea, and we'll look at it in more detail and see a proposed architecture as well. So we'll first look at all the other options that we just saw in a little more detail here. So we've got data integration with polling. Starting off with polling, as I mentioned, it is a very old technique, been around since the 2000s, and then we request data at a specified interval, right? And then this is again a disadvantage of polling, that we're unnecessarily bombarding the server with requests. Not all of those requests are going to be fruitful in every situation. So Zapier is a platform that did a survey internally among the systems to see how effective polling is, and they came up with a number that says it is just 1.5% efficient. That basically means that 98.5% of the times the requests did not have any meaningful results coming back with polling. So that is something that says a lot about the efficiency of polling. And then, of course, there is a trade-off between efficiency and the easiness of a system. So it's easy to adopt, it's easy to add this option to your legacy systems, but again, it's not a very effective one. All right, and then the important fact to note here is the time interval that you set for polling is very important, because that is inversely proportional to the factor of real time data that you get. So if if you're polling for every 500 milliseconds, then that becomes your factor of real time, right? If there was something else that occurred within the 500 milliseconds, you're going to miss out on that one. So the interval is really important. All right. The next thing is streaming, of course. And this is the most modern solution out there. It's real time. The purest, in essence, this is the purest real time integration technique that is out there. But again, as I mentioned, there's a trade-off between performance and easiness of the system. So this is going to be a really hard one to implement, and a complicated system to build. And that is where our organization shines the most. Egan has been using stuff like Kafka in production for years now. We've got a lot of experience with streaming services. We've held, as Praveen mentioned before this, we've held customers in different domains to adapt with streaming services. So this takes a single event processing approach instead of the regular batching approach. Oh, I'm sorry, guys. Okay. So examples for streaming based services are Kafka, and then you have cloud services like AWS. Okay, I'm going to take a short break and then come back.
Yeah, that's okay. I should play some song here, no? Some sort of interval here. Okay, let me find that out.
You could play some elevator music, Praveen.
Yep, that's what I was looking for.
Yeah, I think I'm good to go now. I'm going to try my best to keep up, but keep those comments coming. I like them. Samir says it's 3 days already, so I'm going to try and keep up with the pace of your comments, guys. All right. So as I was talking about streaming services, we all know Kafka is one, and then all cloud providers in general have one or the other streaming service. All right. So coming to REST hooks, as I mentioned, the concept is very simple. What you do is, instead of pulling, we follow a push model in this case, where your client registers with the server and gives them a callback URL of sorts. And then whenever the server has new data, the server is going to push that data back to the client. And then this is a relatively old concept. It is not a new one, right? It's been around for a long time. It's a great combination of efficiency and simplicity at the same time. And because, as I said, this is simple, it is easier for legacy systems to adapt with as well, with minimal to low effort. So you could put it as polling would be the simplest thing to do. Right in the middle we have rest hooks, and then at the top we've got streaming, right? And then rest hooks subscriptions can be used to automate hook registrations, and we're going to look at that in much more detail, of course, if my vocal cords allow me to do that. Cool. We've got the proposed architecture right here, okay? And we're going to talk about subscription management. So this is a module that is going to help us in registering all the clients that want to subscribe to our data service. And then a hook registration schema is essential because you want some information from the client, where to send that data back, right? And what sort of data does that client require? So we're going to filter out data before we send out to that client. And then even propagation service would be a service that takes in our internal data, filters it out, and sends it to the client. We've got network access and security, because all of this is going to happen over REST services, HTTPS. We've got to make sure we have enough security with each of our servers. Failures and retries. We cannot always rely on the network. There are going to be failures. So appropriate retry mechanisms where it applies. And then if there's too many failures and the retry logic just doesn't work out, we can always employ a dead letter queue, which also helps us preserve the order of these messages. And sometimes ordering is very important, right? All right. So this diagram is essentially the last slide put in a diagram form. On the left, we have consumers, and on the right, we have producers or the data owners, right? We have the subscription API that is basically going to let us register clients on our side. So we are going to store all the subscriptions in a database, right? And then we're also going to put those subscriptions on top of a queue. Now, why this queue? Because we've got another service that is the hook service that takes these subscriptions, maintains a local copy of these subscriptions, and then any internal event that occurs, right? Any event that is triggered, we take the local subscription copies and then send out the data to the appropriate consumers. And this is going to be over HTTPS post. The retry logic is handled within the hook service, and let's talk about these modules in a little more detail. Subscription management provides all CRUD endpoints for for registering your webhooks, and then it puts it on a queue. The client is supposed to provide you with event type and consumer ID. These are factors based on which the data will be filtered before sending out to the customers. Now, it is essential that the hook service is independent of your subscription service or the registration service, right? Because that follows the single responsibility principle of the architecture. And then you might have an optional UI for registering your webhooks. In this case, they would be called webhooks because that has a web interface rather than just plain alone REST APIs. On the right, you could see a diagram or a screenshot of GitHub. GitHub has a very nice integration with Jenkins, where anytime you have a commit on GitHub, it is going to send an event to Jenkins, and Jenkins can then run your builds or deploy your code, hence the continuous integration and deployment pipeline names. Okay, so the hook registration schema. It could look something like this. Now, this is not necessary. You could have whatever you want. This is just an example. It could have an ID, and this is the important thing, the payload URL right here. This is the URL that the data is going to go back to. You could have help check endpoints if you wanted to, and then stuff related to security. All right. And then we have got the event propagation service. This is a service that listens to the internal events and is subscribed to internal topics. As soon as the data comes in, this event propagation service, it goes to the local cache and finds the appropriate subscribers for this particular data, and then sends the data out. And then, of course, as I mentioned, it has the retry and failure logic as well. You got to exponentially back off and try and resend the message every few minutes or something. And then even if that fails, again, put it on a dead letter queue, preserve the ordering, and then see what you can do with that data later. Security, as I mentioned, is again a crucial thing to be addressed. If your consumer APIs are firewalled, you got to work with your network teams to get that resolved and get your IPs whitelisted and allow access. And both the subscription API and the hook service must have strong authentication mechanisms in place so that your REST APIs are secured. All right. Interesting part. I'm going to do a very quick demo on a very simple service that I wrote. So here's IntelliJ. Okay. So I've got a consumer service and a subscription service. So my consumer service just has one endpoint, and that's it. It is going to get updates from the server, and it is going to log it on the screen. But the interesting part here is going to be when we register this client or this consumer with our server and see the server sending the messages out, right? So this is the subscription service that is responsible for sending the messages out. Sorry, this is the service responsible for registering the hooks. And within here, I've got a controller that has basic CRUD endpoints, right? So this is for adding the hook itself, the update hook. And let's look at the entity. So I've got this very basic entity. It has the ID, URL, and company name. And as I mentioned, you could do anything you want with this. Add in extra fields, request extra fields from the consumer, stuff like that. This is the URL that we're going to send the data back to. So that's your controller. I've got appropriate service layer and repository layers as well. And then, as I mentioned in the slides, it is essential that you have your hook service and your subscription service as two different services. But for the sake of simplicity and for the sake of this demo, I just put a utility service in the same project. And instead of using Kafka, I'm just replicating or mimicking what Kafka would do in terms of producing the data here via in-stream. And for each integer that I produce, I'm taking it and forwarding it to whatever consumers that I have to those consumers URL. So that's that. And let me actually start the server. Okay. Yep, the server started. Let's go back and try and see if we can get Swagger. All right. So as I mentioned, very simple model right here. We're going to add our client and register our client with this registration service. And so I'm going to say client ID is Egan. Company name is also Egan. And then my consumer is running on localhost 8081. And then I'm going to copy paste a few things, just the context path. And then also it says updates. So yeah, so we've successfully registered with the service. Now, what's happening is we're getting messages, or rather sending. This is the server sending the message to the client, and on the client side, it's basically receiving the messages and as I mentioned, logging it out on the screen. But circling back to our McDonald's example, this would be the McDonald's POS system where they added just a single post endpoint, right? All they had to do was add a post endpoint to get this data, and the real-time data flow starts. They start getting the data, and they could do whatever they want with that data. So if that's an order, then start preparing a delicious meal for the customer, stuff like that. All right. So that is the demo, and let's get back to the presentation. Yeah. So come back here. All right. So there's some key takeaways from the demo and the presentation that we just did. And the first one is, of course, we've got to stop the polling madness. It's not an effective solution. In the most basic sense, you just again creating unnecessary overhead on the server by repeatedly calling the server so many times. So let's just stop that and move to automating hook registrations with a secure API. So rather than polling it, push the stuff from the server to the client, right? And use a API as it was proposed in the architecture, a secure API for hook registrations, and then apart from the payload URL, of course, you can have the health check URL so that you can monitor the health of your consumers. And then always use an event stream internally, at least, so that you can trigger those events and push them out to the client on the specified payload URL. You can monitor the performance and scalability of the event propagation module, right? So if there's something, if the performance is not up to the mark, then again, this is a microservices architecture. You can horizontally scale things, right? And then retries and dead letter queues is something very important. Again, don't rely on the network and don't miss the packets out. Of course, if you're sending sensitive information, you always want to be important and vital information. You always want to be sure that it reaches your consumers. And if it doesn't, then you put it on a dead letter queue and again go back, revisit it after some point and see what's up with it. Event ordering is important in many cases. You don't want to lose the order of the events, and that is why DLQs are very important when the retry doesn't work. If you can, and then at the end of it all, the key concept would be this works when you have a legacy system, REST hooks and webhooks and all of that works. But if you can, and if your consumers can initiate the connections, WebSockets and server-sent events are something are emerging. Not WebSockets, but server-sent events. It's an emerging concept that we could look into. All right. Any questions, guys? I would be happy to answer questions if I can, of course.
I think Ranvit had a question, so go ahead, Ranvit.
Yeah, two questions. First was when the hook service gets an event that it has to send out, and then it goes through its list of subscriptions and callback URLs that it's supposed to send this data to. It has to do some filtering logic to see if like a certain subscription wants to receive this data, right? So like, where would that code sit? I'm imagining like, won't that be a really expensive computation? Like you'll iterate through every single subscription to check if it wants to receive a certain event, right?
Yeah, that's an excellent question. So, and to tackle that sort of stuff, what you can do is, if you have that many consumers that you think the computation is going to be expensive, you could divide it again into different microservices where, and the Kafka topics for each consumer might be different. So in that case, you don't have to make that computation and filter. The data is filtered out at your streaming level. The data coming in from Kafka is from different topics, and then there's a separate hook service for each of your consumers that is sending that data out.
Okay. And the second question was like the very last point you just made on the last slide, which is that if the client who's consuming your data is willing to implement some code or modernize their architecture, you were talking about server-sent events.
Yeah.
And I don't know what that is, if you could explain that, but also why can't the consumer use the streaming approach if they are willing to implement like?
Yeah, sure. So yeah, of course, streaming is something that again, as I mentioned, it's a complicated thing to be achieved. But server-sent events again is one layer less complicated than the streaming architecture. What happens with server sent events is, again, it's on HTTP, it's a HTTP thing. It's easier for the clients to adopt. Once you open a server sent events channel, the server actually sends out a stream of data over HTTP long polling. Internally, it's long polling again, but it's supposed to be more efficient than regular polling, and it sends out events back to your client. So it keeps the connection open as long as the server has got events to send back to the client.
Okay, so it sounds like in this case, the server won't get overloaded by polling requests from the client in the case of SSE.
Yes. So again, internally, I think it does it in a much more efficient way rather than us pulling it every few seconds. But Praveen, add on to this, please.
Yeah. So a couple of things there. First, definitely yes. There will be a long-running connection. Let's say it that way, right? So on HTTP, when you open it from client to the server, usually after the server has sent the response, the connection can be closed, right? In case of server sent events, the client will be initiating that connection, upgrading it, and then the server will keep sending the event or keep pinging or heartbeat kind of a scenario. The connection will not be closed. We are implementing both of these patterns, WebSockets as well as server sent events, in a couple of our similar scenarios where we wanted to move away from polling, but then client only wanted to read the data. They were never sending the data back to the customer, right? Or sorry, to the server. So we went ahead with server sent events also. There is an event coming in Kafka Summit Europe. One of our engineer, Gagan, is actually going to be presenting. He's one of the session speaker there in Kafka Summit Europe, somewhere around May, I think. And then the whole focus is to talk about server sent events using Kafka and some other frameworks.
Okay, thanks.
Cool. Anyone else? Any other questions on anything so far?
So I think just to expand on that, if we were to use server sent events in this architecture, how would you implement that? How would you design?
Yeah, so the subscription logic that you saw before, right? If I go back to this, too much. I came too back. So when you want to implement, let's say, WebSockets or server sent events, this logic that you see of the subscription event, subscription API and things, that will not exist. That will not exist. What will happen is your consumers, whenever because it's a consumer initiated request, right? So they can just talk to your backend SSE server as normal, and then it's just that connection will be kept open, and server will keep sending data on the same connection. So there will be no subscription management if you think about WebSockets or SSEs.
Got it.
Cool. Anything else? Anyone else? Any other question? Perfect. So thanks everyone, and especially thanks to Arif. Hopefully you go home. You are already home, and then you mix and gargle. Don't read too much on WebMD, okay? Everyone dies in the end. So that's one of the things.
When did you add that slide, Praveen?
Slide updates in real time, dude. That's what we are talking about. Cool. So that's pretty much what I had, what we had for this particular summit, this particular meetup, and we have some more things coming up. So just wanted to update what are some of at least 3 more events in the next 6 weeks or so. So head over to meetup.com/cloud collective or collective.ac. 2 weeks from now, we will have Varun talking about reviewing, or he will provide a review of cloud managed CI/CD services, right? So you may have heard about all the 3 cloud providers having some sort of managed CI/CD service, whether you are talking about Azure DevOps or DevOps pipelines, or AWS has multiple services for that, whether it's code build, code pipeline, code deploy, or also Google has Google Cloud Build, right? And then you have GitHub, and GitHub is also having GitHub Actions. So This particular meetup is going to be focused on reviewing all of them and then also seeing what are the comparisons and configuration for each one of them. So that's the whole idea. 4 weeks from now, I will be talking about a complex subject that we have been using for some of our customers, specifically about service mesh in the Kubernetes environment. So it will be 2-session kind of meetup. So in the first one on March 25th, a month from now, so we will be having an intro level discussion for the meetup, mostly about what are the use cases, some high level understanding, and maybe an overview of Kubernetes before. And then a week from then, we will be actually going or diving deeper into some of the advanced configuration that we will have with respect to the Istio and how to configure it, how to deploy it, what are the pros and cons, but then also how to take care of a lot of those advantages that those are coming from Istio. So that's pretty much it for today. If you have any questions, let us know. Otherwise, thank you for joining. Talk to you in 2 weeks.